Our third and final lesson in Unit 1 is writing numbers in standard and scientific notation. Scientific notation is a method that mathematicians and scientists have developed in order to write really, really large numbers and really, really small numbers in a quicker format. And this is done using the basics of the base 10 system that we have in place here. The basics of that is each place value is worth 10. So each time you hit 9 in a specific place value, you have to move up to the next place value and begin at 1. So that's how a base 10 system works. Each place value in a number, no matter how large or how small, is worth 10. So this helps us not have to write really, really large or really, really small numbers multiple times. We can write it in this scientific form, and it makes the process much faster. I'm going to go ahead and show you how to do this here on this first problem. So we're going to start with the number they've given us. It says represent 0.023 using scientific notation. We're going to start by writing out that number so that we can manipulate the information. The biggest rule for scientific notation is when you move your decimal, which is how we're going to get to our scientific form, when we move the decimal, it needs to be moved behind the first value in the number that is between 1 and 9. Your number cannot be smaller than 1, and it cannot be larger than 9. You can only have one digit in front of the decimal. So in this case, the very first number that is between 1 and 9 is this value of 2. So we need to move our decimal a number of place values so that it sits here behind the number 2. So in that case, we are moving it 1 place value, 2 place values. So now that we've moved the decimal, we're given a new decimal value. So we're going to write out that new decimal value, which is 2.3. But this doesn't tell everybody else that we're writing in scientific notation. We're going to do that by multiplying by 10, because each place value is worth 10, and we're going to raise it to the power of the number of place values we moved. So in this case, we moved 2 place values. We moved 2 place values to the right. So that's going to make our value a -2. So now you're asking, why is it negative? Why is it not just 2? Allow me to explain. You can have a positive or a negative exponent on a number in scientific notation. The positive and negative exponent simply tell us whether the number is really small or if the number is really large. If the number is really small, your exponent is negative. If your number is really large, your exponent is positive. I have a quick way to help you remember whether your exponent should be positive or negative. If your zeros are in front of your number, zeros before, your exponent is negative. If your zeros are behind your number in standard form, zeros behind, then the exponent is positive. So in this case, in the standard form, our zeros were in the front of our number. Meaning, in order to move to scientific notation, our exponent needed to be negative. If our exponent was positive, that would tell us that the zeros were behind the number, and it wasn't a decimal, it was in the thousands. Now, the important thing to note is that your negative exponent does not affect whether your value is positive or negative. For example, this question here says, represent negative 0.023 using scientific notation. So we're going to again start by writing the value that they gave us. This time they gave us a negative 0.023. We need to determine first, are our zeros in front or are they behind our number? Our zeros are in front of our number. So the first thing you can note is that we know we're going to be multiplying by 10 to the power of something. Since our zeros are in front, we know that our exponent's going to be negative. So we'll just start with placing a negative up there. The next thing we need to do is determine how many place values do we need to move the decimal to get the decimal behind the first value in this number that is between 1 and 0. Sorry, 1 and 9. What is the first value in this number that is between 1 and 9? It's the 2, correct. So we're going to need to move our decimal to that point right there. Now we need to count how many place values we need to move in order to get there. So we start where our decimal is. We move 1 place value, 2 place values. There's our exponent. Our exponent is 2, negative 2 place values. The last piece, we're going to take the new decimal that we have and bring it down here to the front of our problem. This time we need to make sure we include a negative because this number was negative to begin with. So we have a negative 2.3 times 10 to the negative second. Okay, so we're going to go through a little bit of the modeling of the thought process you need to travel down while you're solving these problems. So this says convert 0.00045 to scientific notation. Well, we know we're using scientific notation. So our answer is going to be times 10 to the power of something. We can always start there. The second thing we need to look at, are the zeros in our standard form in the beginning or the end of our number? These are in the beginning of our number. So does that mean our exponent is going to be positive or negative? Our exponent in this case is going to be negative. Okay, now where are we moving the decimal? What is the first number in this here? What is the first value in the number given that is between 1 and 9? Correct. It's this 4 value. So we need to take our decimal here at the front of the number and move it behind this 4. We need to count how many place values that is. 1 place value, 2 place values, 3 place values, and 4 place values gets us behind that 4. Now we know our exponent. Our exponent is -4 place values. We take our new shortened decimal and we write it at the beginning of our scientific notation format. So what happens in this situation? We have 8,600,000 and they want us to convert that into scientific notation. The process is the same. We know we're going to be multiplying by 10 to the power of something. We need to move our decimal behind the first value in this number that is between 1 and 9. Which value in this number is the first value between 1 and 9? It's not the 6, because if we put the decimal here, we have 2 values in front of the decimal. Remember, we can only have 1 value in front of that decimal number. So the very first value between 1 and 9 in this number is 8. A good way to think about this is we read from left to right. So when we're looking for the first value that is between 1 and 9, we're talking about the first value in the direction that we read the number. So we need to move our decimal right here behind this 8. But now there's no decimal written in this problem. Who remembers where the decimal is assumed to be when it's not written in your number? Right. We assume the decimal is here at the very end. So we need to count how many place values we need to move this direction to get our decimal between the 8 and the 6. Now, before we move it, is our exponent going to be positive or is it going to be negative? Well, are our zeros before the number or behind the number? In standard form, our zeros are behind the number. That means our exponent will be positive. So I'm just going to write a little positive sign up here to remind myself that it's going to be a positive exponent. So let's count how many place values we need to move to get our decimal from the end of our number to positioned right here between the 8 and the 6. 1, 2, 3, 4, 5, 6 place values. Our exponent is based on the number of place values that we've moved. Lastly, we need to write this new decimal right here. Our new decimal is 8.6. Lastly, you're not just going to have to write a standard number in scientific notation. You're going to have to be able to take a number that's given to you in scientific notation and expand it to standard form. And it works pretty similarly. We're going to go through the same thought processes in a bit of a different manner. So this says convert 8.7 times 10 to the third into standard form. So what we need to determine is which way are we moving the decimal and how many place values are we moving that decimal. This says that our exponent is 3. It's a positive 3. What do we know about a positive exponent? We know that our zeros in standard form should be behind our number. So that means we're going to move the decimal further towards the end of the number. So in this case, I'm going to write the number they gave us, just because there's not really enough room to expand it here without running into the rest of the problem. Now I'm going to take that decimal. How many place values am I moving it? 3 place values. I'm going to move it 1 place value, 2 place values, 3 place values. Moving at 3 place values, I have a couple empty spaces. What do you suppose I put in those empty spaces? Yes, I'm going to put a couple zeros in there just to fill the holes. So in standard form, 8.7 times 10 to the third is 8,700. If this had been a negative exponent, we would have moved the decimal to the left so that when we expanded to standard form, our zeros would have ended up in front of our value. So why do we use scientific notation? Does anyone remember what I said in the beginning about why we use scientific notation? Right. It's a quick way for us to write really large and really small numbers. I'd like you to work this problem here in the bottom corner on your own. And if you have any questions, let me know.